So this is a great question about how to find the equation of a perpendicular line and a parallel line given an original line. So I thought I would do a quick example from uh, Alex to show this. So we've got our original line, which is this 3x minus 7y is equal to -1. And we want to find the equation of a line perpendicular to that and parallel to that, and both of those lines need to go through this point, -5, 3. So the first thing that we're going to need, I've got it written right there, number one is we need the slope of the original line. It is sadly not 3. We need to be in slope-intercept form to be able to read our slope of our line just right from the equation. So we need to subtract that 3x from both sides because we need to solve for y. We need to get y all by itself. And then we need to divide everything by this -7. And I prefer to write this as that I'm dividing each of those individual terms by -7 instead of the whole right-hand side by -7. It's like I'm using the distributive property with division because I need to divide each piece. And it just makes me a little bit easier for me to find the equation of this line. So I'm going to get positive 3/7 x. Again, that's positive because we've got a -3 divided by a -7. So those together make a positive answer, and we can write that 3/7 out in front of our x. And then we've got a -1 divided by a -7, so that's also going to be a positive 1/7. So here's our original line, and its original slope is 3/7. So our parallel line is going to have the same slope. It's going to have the slope of 3/7 because parallel lines, they don't intersect, so they have to have the same slope. That's actually a pretty decent job drawing parallel lines freehand, but they've got to have that same exact steepness or they will eventually cross. Our perpendicular line is going to have a slope that is a negative reciprocal. There we go. I'm going to give myself bonus points for actually spelling negative reciprocal right. So we've got to flip over the original function and make it negative. And if we again think about and picture perpendicular lines, they make a right angle. If we look at those lines, one of them does have a positive slope, one has a negative slope. One's a little less steep, one's a little more steep. So that reciprocal part of it gives us that one's a little steep, one's a little less steep. So now we have our slopes of our lines that we want to make. We have a point that each of those lines go through. So let's start with our perpendicular line. It's going to have that slope -7/3, and it's going to go through that point -3 or -5, 3. So there's a couple of ways that you can find the equation of a line, and most textbooks, and I'm sure Alex talks about point slope formula, which is this guy right here, which is what you use when you know, or what you can use when you know the slope of your line and a point on your line. So we're going to plug in the slope for slope. We plug in the x value in for x1, the x value of our point, and the y value of our point in for y1. The x and the y that's in point slope, the plain x, plain y, those are actually going to be our variables in the end. So the nice thing about using point slope is that when we use the distributive property and get y all solved by itself on one side, it gives you something that's really nice in slope-intercept form. You've got your equation, it's right there and it's done. But we'll talk about why it's not necessarily my favorite. So we're going to first do the distributive property, going to distribute that slope through both of our terms here. So we get -7/3 x, and then, ooh, maybe I should have put one little step in between here. Maybe that would have been a little bit more helpful. Oops, let's actually be a pen here and rewrite that as -7/3 times x plus 5. Maybe that's a little bit more helpful because it's a little less, three negative signs. That is not fun. But here we're going to get 35/3. So we're multiplying fractions. Any whole number is that number over 1. So we multiply across the top and across the bottom. So 7 times 5, which gives us 35, 3 times 1, which gives us 3. So then we just need to add this 3 to both sides, and then we've got our line in slope-intercept form. So yeah, it's kind of a pain. We got to add fractions here. But what's nice is we're adding a fraction to a whole number. So that 3 just like that plain old 5 we had up above, we can write that as 3 over 1. And we can give it a denominator of 3 by multiplying it by 3 over 3. So 3 is the same as 9/3. So our line is y is equal to negative 7/3 x minus 37/3 plus 9/3. So simplified, we get y is equal to negative 7/3 x, and then plus, nope, minus, excuse me, minus 26/3. So there's our equation of our parallel line. So this is one of the options of how you can do this. You can do this with point slope. I actually kind of like to solve these using slope-intercept form. And I kind of like to do these parallel because what I want you to notice is all the same numbers pop up. We're doing the exact same set of operations. So here we're going to put our m in for our slope. So we know that our slope is negative 7/3 x plus b. Then we also know if we plug in this point we're given, negative 5, 3, I'm going to say this a different way, that if we plug in negative 5 and add whatever our b is, we technically know what it is, but this is our second way of finding it. But we should get 3 out as an answer. So we can use this point along with our slope to find the y-intercept, and that's exactly what we're doing with point slope. So notice what we need to do here to solve for b is we've got to do this multiplication we've got right here. We get 35/3. We've seen 35/3 before. Look over here, 35/3. It's the same number. That's not a coincidence. And I left off our plus b there. And then to solve for b, we just have to subtract 35/3 from both sides. And if you look at what we have here, we have 3 minus 35/3. What do we have back over here? We have negative 35/3 plus 3. It's exact same thing. So we're doing all of the same operations. Nothing is really any different at all. It's just kind of the signs are a little bit swapped, but while you're doing the operations, but we still ended up with the same y-intercept. So it's completely up to you how you want to solve these, but you have two choices and you can choose which one you want to do. It's your choice. So I'm going to do this y equals mx plus b method one more time with the parallel line, and that's mainly because I like that method the best. I like it a little bit better because I have a bad memory, and so I don't like to have to remember more than one form of a line. So I just like slope-intercept form. But you should try it with point slope and figure out that you are going to get the exact same thing that I got. And so again, what we're going to do is plug in that slope in for our slope in slope-intercept form. So we're going to get y is equal to 3/7 x plus b, and then plug in our 3 for our y value, our 5 for our x value, and then we're going to multiply here. So again, we've got that fraction times a whole number. So we're going to get negative 15/7 there. Negative 15/7 plus b. So we're going to add 15/7 to both sides. And again, yes, we have to add fractions, but that 3, we can turn it into sevenths by multiplying it by 7 over 7. So 3 is the same as 21/7. So 21/7 plus 15/7, that's what our b is going to be. Let's see, yes, I can actually do this addition in my head. So for our parallel line, our y-intercept is 36/7. So we get the equation of our line is that it's y equals 3/7 x plus 36/7. And with both of these lines, you can always check them by going back and plugging in negative 5, because we better get 3 out as an answer. And if you go and grab your calculator and type this in, you will get 3. So that's a quick way to check. Another way to check is to graph all 3 of these lines. To graph our parallel line, this guy right here, our perpendicular line, the guy there in pink, and our original line. And actually, I'm even going to graph the original line in that standard form. And hopefully, there we go. There we are. So the red graph is the original line. Then the blue graph is our perpendicular line. Our green graph is our parallel line. And then I also plotted the point negative 5, 3. So you can see that that point is on both the green line and the blue line. So our parallel line, our perpendicular line, they both go through that point. They're parallel and perpendicular to that original line, which is what we needed. And you can also see on the original line, when we solved that, got that in slope-intercept form, We got a y-intercept of 1/7. That's the approximate value of 1/7. So this is another quick way to check to make sure that everything you've got is right.